space where they had to run some underground utility for their hotel expansion, which is due to be complete at the end of this year. We attended a city council meeting, and some of the city council members were concerned that they were going to be tearing down this historic piece, and had suggested that perhaps the museum would be interested. And when I spoke with the CEO at the time of Sands, he had said, there's no way, we've had experts in, there's no way you're going to be able to move that. There's cracks all throughout it. Once you try to pick it up and move it, it's going to fall apart. I said, well, could you at least just give us a chance? Let me see. And of course, Andrea, with her amazing connections, had gotten in touch with Jim Romeo, Lehigh Heavy Forge, who's here with us today, and he said, I got the guy for you. And I mean, honestly, it was like everything fell into place. We sat down at a meeting with the folks from Wind Creek, and any concern, or sorry, Sands at the time, any concern they had, Nick Lykon had just said, nope, we're going to do it this way. This is how we're going to do it. It's no problem. I've done it before. And it was almost their jaws had dropped. We walked out of that meeting, and I think that, you know, the piece that got them hooked was the fact that Nick said it's actually going to be cheaper to relocate it than to demolish it. And then their ears perked up after that. So that conversation, I believe, started taking place in February timeframe, 2019, and the move was complete in September 2019. And I remember at the time, then they had a transition of their CEO, Kathy McCracken, had come in, and towards the end of the project, she said, I've never worked so long on a project. I'm just going to be so happy that it's over. I said, are you kidding me? This is the fastest that we've ever done anything, because things work slow in a nonprofit. But anyway, Andrea and I say all the time, he's like our hero. So with that, I'm going to introduce Nick Lykon, who is, what's your title now with MEI? General Manager. AMA Machinery Moving, which is now a subsidiary of MEI.
We're AMA Machinery Moving and MEI Company.
Okay, here's Nick.
Mike, thank you for the history. I've learned some of the history as we were going through relocating the press, but I was excited today to come and learn more of the history about what was going on. So that said, we're going to advance through the first 3 slides because I think Mike covered it pretty good. There we go. So as we talked about earlier, the press was in the traffic circle over there outside of the Sands Casino, and it was about 100 feet from the entranceway to the casino. So talking about the way that they were going to move the press or scrap the press would have caused a lot of disruption. If anybody has ever seen using an oxygen lance or cutting a heavy piece of metal like that, they probably would lose vision of the front entrance in that process because of the smoke clouds that would come off of it. But so the proximity to the front of it was an issue, and then also getting it through the facility. Go ahead and advance to the next slide. So we were starting, I'll try and stand off to the side, maybe that'll be a little bit better. We're starting from the traffic circle over by the press, and then we were going to move here to the museum. One of the important things of moving it is we couldn't get on a public road because of the amount of weight that was being moved and the load on the streets and stuff. You couldn't go over any bridges, couldn't do. So I know we were originally talking about a couple of different locations of possibly moving the press to, and the location here was the best for us to be able to move it to. Go ahead and advance to the next slide. This is the existing casino location, and I would say everybody that's here is probably familiar with it. Next slide. And there we are. You can see the proximity to the entrance to the casino. Next slide. We talked about the press, or Mike talked about the press earlier, and there's different components to the press, and we're going to break that down. This is one of our original meetings. This was shortly before we met with Wind Creek Casino, and I'll elaborate a little bit on that meeting. I think it was Andrea, Kara, and Charlie, we went to the meeting, and they had a team of engineers there to tell us why we couldn't move the press and how we couldn't move the press. And, they said, the ground impact as we passed the different buildings here would affect the buildings, and if we picked it up with the forces on it, the crown would crack and break. It already had some cracks in it. And traditionally, when you're taking a press like this apart, you're taking it apart to put it back together. So you have to take the crown off of the columns. And if it twists at all, or as this one sat outside in the rain for, 20 or 30 years, there'd be a lot of corrosion. It won't come off the columns easily. But we had come up with a technique to go ahead and cut the columns and be able to weld them back together. It wasn't going back into production, so that gave us the ability to do that. And so we were able to pick the crown with the columns, which didn't require that extra force. For example, we did the 3,000-ton press over at Lehigh, and we ended up with 12,000 tons of jacking pressure to get the crown to come off of the tie rods. And that was a press that was in operation up until they shut it down. So some of their arguments would have been valid, except they didn't have alternate approaches of how we did it. Let's go ahead and go to the next slide. Talked about the history already, as far as Wind Creek said, we're going to scrap the press. The museum said they wanted, the city said we wanted, the community said, no, you're not going to scrap the press. So thanks to Jim, we had this opportunity to step in and help move the press. Next slide. So Wind Creek, again, said couldn't be done for lots of reasons. Next slide. The museum obviously due to the historical significance, and they says, we got to figure this out. We can't let the press go to scrap. Next. And then the community, and then we got involved. Next. And so a couple of things that we did differently. One of the most expensive parts of the press to move is the base that was left underground. But we didn't need the base to put the press together here. We could replace it with a concrete foundation. So we left the base in place. We wire sawed the columns and then re-welded them when we got over here on the other side. And so now we're working our way through the meeting. I'm going to jump back to the meeting, and we're 40 minutes into the meeting, and they're still telling us every reason why we can't move it. And then we kind of held back a little bit, and I says, well, we believe we can move it for less than it would cost you to scrap the press. And all of a sudden, the tone of the meeting changed, and they wanted to pursue those options and see, and they got much more interested. And so, fortunately, the partnership, everybody came together. The casino was a great host for us when we worked over there. They had security there, they had things, so they really helped out to make this happen, and I'm sure they helped on the funding side of moving the press. So let's go next slide. Challenges: we're unable to traditionally mechanically disassemble, which we talked about. Unable to move it in a single unit. We could not get to pick the crown off, let alone the whole unit. We couldn't get a crane large enough into that location in the traffic circle where we were. We couldn't get a crane big enough. I mean, we had, I think we had a 250-ton crane when we picked the smaller pieces up, but we would need at least a 600-ton crane that just wouldn't fit in that envelope to pick the crown off. Another challenge we had is, I know there's been a lot of information that came over time, but at that time we had very little information on the press. We didn't have weights, we didn't have any mechanical drawings, we just had some pictures of when the press was put together. So estimating weights and doing things like that was always a challenge. I always say it's harder to move a piece of used equipment than new equipment. You move something new, you know everything about it. They've designed it, they've engineered it. You move something used, but you think about something used from 1891, it's really a challenge. And the structural integrity of the press. There's some things we did about how we slung up the press to equalize the loading. We'll talk about that. And then the anvil itself on the bottom was broken in half, I guess, from operation. It's a 100 and, I don't remember the weight here, but maybe 40 or 60,000 pound piece of steel that was broken in And then materials. So we didn't know what our materials were. We didn't have any documentation. So different welding procedures. You can't just weld to anything. You have to know what you're welding to. You have to have a certain procedure. We asked Lehigh Heavy Forge to send over the metrology people. We took some samples out of it. They did some sampling for us so that we could determine what was the carbon content, what was the material that we had, and what welding procedure we could weld to this to have it stick and work. Because for any of you guys that know, or gals that know, you can weld a piece of steel to a piece that doesn't match and hit it with a hammer and it'll fall off. Let alone pick up 100,000 pounds with a lifting lug that you're welding on. And then routing, we had to come through, and there was, it was difficult of how we were to get through. We went through 2 shops here. It was a real narrow passage, and they were concerned about the weight, the concentrated load of the heavy crown affecting the foundations of these buildings that were barely standing on their own. You could see, I looked in the buildings and you could see it shifting, and the building shifting on the foundations. But thanks for the team. They had engineering studies done and everything that proved that to be safe. And then the media event. We're 100 yards from the front door of the casino, and we have full surveillance every time you do everything you do. But it worked out well. We kind of had a pen area where the newspaper reporters and people were. Tony, sitting in the back on our team here, did me the favor to come and manage that so that the team didn't have to manage doing the job as well as answering the questions. So it worked out well. Next slide. So here we're talking about the components. For those that don't know the components, here's the crown of the press. These are the cylinders and rams. So the rams would be the black part, and the cylinder would be the piece up in the crown. So the crown is a big block on the top, and there's actually cylinders inside there that is the piston. The moving crosshead, that's the piece that does the work. There's 4 tie rods or columns, and they actually, at ground level, go in the ground about another 12 feet through the base, which was abandoned underground.
So what was the base? Was it a big steel base, or was it concrete and stone?
No, it was a steel base. That was.
How thick?
I don't know how thick it was. We just saw the bed plate on the top of it.
It was different.
Yeah. I understand that they may have removed it at some point in time when they built the casino.
Yeah, they had to break it up, so they had beam come in, heavy jackhammers.
Yeah. So the anvil is all the work is done on top of. Okay. And then the base, which was below grade. If you look out at the unit out here and you look at the concrete, that concrete was made in the shape of what the base would have looked like. The upper nuts, the next intermediate upper nuts, the lower intermediate nuts, and the bottom underneath the ground would have been the lower nuts, or the bottom nuts. So what you're looking at normally in a press assembly, between the upper nuts and the intermediate nut, the way they tighten those up is they heat the rod until it grows. They'll turn it by hand or with a big bar until it tightens, and then they'll let that cool, and that shrinking of the tie rod would create the torque that's associated with tightening that bolt. They don't have a wrench big enough to put on that nut and turn it and get the tension. So typically they're heating it. They had holes drilled through these tie rods that you could run steam or heat to heat the tie rods up. Okay, next slide. So this is where we made our cuts with a wire saw. So a wire saw is a rope, a steel rope impregnated with diamond. And so they take that rope and just pull it across, and you'll see that. And because the diamond is harder than the steel, the diamond will abrade the steel and cut through it. And since typically you would cut that with a torch, but we had to reassemble it. And to cut it 18 inches thick with a torch, you end up with a 6-inch gap. You would destroy the piece of equipment. Next. So the press components: crown, cylinders, rams, tie rods, moving crosshead. Tie rod sections, there were 4 sections that we kept. The anvil, which was broken, there was a big crack right across the middle. You could see just a little bit of it in the bottom right corner underneath the beam skin. This is some more drawings. Again, there was another contractor that was used for developing the park, I think, Simone Collins. Yeah. And they did some studies here. Next. And then these were the estimated weights versus the actual weights. Now, we don't have a drawing to work from, so it's a matter of going up there, measuring the parts, looking inside, saying, okay, there's a hollow cavity up in the middle of this, and that's approximately this big. And we estimate around the columns there's a gap of about, even though we can't see it, of this big. And so you take all those little pieces and you put it together and estimate your weights and calculate your weights. So we estimated 400,000 pounds. Next. The moving crosshead, 80,000 pounds. The tie rods, the sections between the yellow lines, 12,000 pounds each. And the anvil, 158,000 pounds. Then the actual weights, the crown came in at 398,500 pounds. The moving crosshead, and we got some brownie points for this later on, I'll talk to you about. And then the tie rods, 12,300 pounds. And then the anvil at 156,000 pounds. So, I don't know if I was lucky or if we were just good, but it's not normal that you get that close. And on the crane, which handled all the small pieces, not the crown, there's electronic scales on the crane, so we had actual weights. And on the crown, we used our hydraulic gantry. We can read the hydraulic pressure to give us what the weight of the crown was. Next. Again, you heard the conversations earlier about cracks. These straps that are on there is to hold the press together. These would have all been done during the operations. If they're offloading the press and they don't have their forging right in the middle and they have it off to one side, Jim knows what this is all about. It causes all kinds of forces and pressures on the ground. So, and this was cast, so it does break, it doesn't bend. Next. Pieces missing. Next. So the wire sawing, that was key for us to be able to do this project. Wire sawing isn't traditionally used for cutting steel, it's used for cutting concrete. But my thought process is inside of all concrete there's steel rebar, so they got to be able to cut through the steel. So I reached out to a wire saw company and they said, yeah, no problem, they could do that. It's amazing some of the stuff that they do when they cut. One of their projects, I'm going to side rail here for a second, they were doing stacks in cruise ships, and every day that the cruise ship is in the dock, it's $1 million that they lose. So they were changing the stacks, so the guys would go on a cruise and cut the columns. They'd run on 2 engines and not 3, and they would cut it, weld pieces together so that when they got in port, they can just lift the stack out and save like 2 weeks on their schedule. So they had crews out on the ocean cutting out one stack while everyone was cruising. Understanding what the material was important. Next. So we cut below the intermediate nuts. We did 4. They were 18. The tie rods were 18 inches in diameter, so it was an 18-inch cut. Next. And then we cut right through the bottom intermediate nuts, right at the lowest part above the base. So we cut through the nuts and the tie rods. And they would we welded some blocks in there to stabilize everything, because you don't want to cut it all and have it not standing up. We welded blocks so that, and drilled holes through those, milled holes through those blocks so they can pull their wire through, cut the column, but yet it's still held together. Next. This is the wire saw. So this saw is running, they're running water on the cut when they're cutting it. They weld these pulleys into position so they can make the wire go where they want it to go. Next. So there are some of the blocks that we welded on the columns. Again, we had to know the right material, the right weld procedure. That actually is the wire, or those little nubs that you see are the diamond impregnated parts of the rope that the wire saw. It's probably going 50 feet a minute. We just wired saw a 400-ton extrusion press apart. We finished that project a few weeks ago. Next. And here you can see in the circle there's a steel wedge there. So as they start wire sawing through, just as those who use the chainsaw on a tree, your saw's going to get pinched. They would drive wedges in so that the piece would settle on their wire, and so they can continue and cut through the other side. This is a short video. So it would take 3.5 hours for that cut. 3, even 4 hours to set up the cut. So as you can see, now we're stacked up, and the press, we've got the moving crosshead blocked up, because once we start picking pieces off, it could topple over. It's only sitting on those beams. Next. We talked about this next. So this is a hydraulic gantry. So a hydraulic gantry is a post and a post that has a hydraulic cylinder in it, and you pick a different beam for your capacity to go over top. So this is a 300-ton, 2-post hydraulic gantry system. It can pick up 300 tons based on the right size beam and the right rigging that's hanging from it. So we go through our beam configuration to make sure our beam is strong enough, and 3 reams means we're good in every way. But we'll run those calculations and run this through a software to make sure that the beam will handle the loads. The width of the crown, the spacing of the columns all affect the structural integrity of the beam. We had 80 foot of track. We had risers. We'll see that a little bit. Next. So here we were dealing with the different elevations. So we were in the bottom of the traffic circle and then up to the roadway. And then we had to create a bridge to be able to move it from one place to another. We used the cribbing and 1-inch plate on top of the cribbing to give us a flat level area, because we didn't start with a flat level area. And then we put the steel beams, and we welded these beams all together, put bigger beams on top. And then the red on the very top is our gantry track sitting on top of the structural. Next. Next. Just some looking at the press from different angles. This is prepped and ready to lift. We're setting the gantry up at this point. Next. So you bring the gantry posts in. Each post weighs about 18,000 pounds. Put the beam on top. They're making the mechanical connection on the top. And you can see we use different beams at different elevations. And we swapped our track as we went down once we picked it up. Next. Another thing that we did is we picked this with one sling. So we started on one side over the rigging, down underneath, over the other side, down under the rigging, back through, and connected it all together. So it was equally loading the whole crown of the press. So if there were, just kind of picture it was cradling. It was slinging the whole thing. We didn't have one sling to this corner, one sling to that corner. We basketed everything all the way through to help equalize the loading. We had no real concern about the press crown breaking, but this is just another added safety step to kind of basket and sling it. And it wasn't easy to manage that. 9-part, 1-inch, 50-foot long sling that probably weighed 4,000 pounds.
Fabric sling that is on a boat lift?
What's that?
The fabric sling?
No, it's steel cable.
Steel cable.
Yeah, steel cable. Yeah, so the way that a 9-part is there's 9 1-inch slings braided together, steel cables. And then 120-ton shackles on the lift links. All right, next. So here's another picture. This is actually after we were already lifting and we're off of the press crown. We're traveling with it at this point. Next picture. The next part of it, which was a challenge, was getting the right trailer to move it. Because of the length of a trailer, if you use a standard trailer that's on a road for moving something this heavy, it would be called a 19-axle dual-lane trailer. It's called a dual-lane trailer because it takes up 2 lanes of traffic. 19 axles, because it has 19 axles front to back. It'd be a 175-foot long trailer plus the tractor, and it would be 18 foot wide going down the road. So you need something with that much capacity and a much smaller footprint, and that's called a SPMT, a self-propelled mobile trailer. And so this is the trailer that we picked to do the job. Every axle hydraulically self-adjusts. Every tire steers independently, so they can crab steer and walk the whole thing sideways. They can turn all four and turn it within its footprint of itself. Let's go to the next slide. So this is the SPMT. The unit where it says K25, that first part is the power unit. There is no tractor, there's nothing pulling it. That unit there is the power unit. It's got a hydraulic pump on it. It drives all the wheels separately. It's not doing 55 miles an hour, but it normally moves at walking speed. If they were taking this trailer down the road, they would take the drive system off and pull it with road trucks. Next. So this is the press crown sitting on the SPMT. It's a 10 line, so that means there's 10 sets of axles. There's 8 tires across each axle. Everyone is hydraulically. Everyone is self-leveling. Next. There's a computer in it too. You know? And so this is our route. We took the press out, came through the passageway, or there's a really tight area. Came across. Originally, they asked us about traveling right through the area where most of the events are, where there's all the cobblestone. I said, no, we're not driving across the cobblestone. There's only sand under those cobblestones. It's not gonna happen. So this was a separate study to determine that we can drive through between those two buildings there. Next. So that was the spot we had to go in and go through those buildings. Next. And of course, to the right is the building, I won't say today, but what it was a couple of years ago, and this is that same building in its heyday. So this is a picture of us. We used a mobile crane to handle, once the crown was off, we disassembled the gantry system, got it out of the way, and we used a mobile crane to pick up the 4 columns, the moving crosshead, and the anvil. And the lifting lugs that are on here, they're set up in an orientation where they all are pointing towards the center because it's a center pick. And you can notice the crack across the bottom. So we had to be careful to be able to pick that up and position those lugs in a place where those two pieces came up together. There were some bolts that were put in sometime in the past, but not knowing the integrity of those bolts or anything, we didn't want it to break and just fall apart. So we positioned those lugs so that we were picking up evenly on those 8 lifting points. And again, welded those down, needed the weld procedure to be able to do that. Next. So we had to put the press crown in first and put it on the ground behind where we were going to build the press, because we didn't have the room to bring the press crown in second, because it would be way out in the street on the trailer. So we unloaded the press crown, we set up our gantries, set it on the ground in the back, same assembly that you did. Put the rest of the pieces in with the crane, and then brought the press crown back. So an important part of that press standing out there today is the design of the foundation and the compaction of the stone and the earth around it. We made some visits out here while they were backfilling. They have to backfill the stone and compact it in 6-inch lifts, because our gantry, if it's sitting on an area that sinks, it goes like this, everything goes like that, it tips over. So it's important that they designed it and they did a good job with the right, and that it's executed as the design says it's supposed to be executed. You know, you can take a backhoe and just put stone in a ditch and it all looks level at the top, but you have to compact it, and they did a good job. And I think Butts was managing that, those subcontractors out there. And what you see in concrete underneath the press is probably a third or a quarter of what's actually there. There's like 8 feet deep,
20 by 20.
20 by 20, 8 feet deep of concrete underneath of it. So I don't expect that you'll see the Leaning Tower of Pisa at any time in the near future.
Is it reinforced, the concrete? Does it have steel in it too?
Oh, yeah, yeah.
So it's
And then
all-
right underneath of where each column sat, there's a steel plate on the top, and they had a rebar cage all through the foundation. Next. So here, we're picking the crown now, and we're moving it back onto the assembly that we did with the base and the columns. So that you can see to the left there, the moving cross is there, head is there, the columns are stacked back up, and they're all just standing there, they're just stacked. We're doing a press project for a couple of automotive companies, Tesla, BMW right now, and that's literally what they call it, stacking. Because you just stack the press parts, they don't bolt together, you stack them, and then they come through and tighten them up later on. So we've got 11 presses around the country that are up to 1.4 million pounds, and new stuff coming in from overseas.
Is that the mega press I keep reading about?
I don't know what the mega press is, but
Giga
I-
press.
the what?
Giga press, they call it.
Giga press, okay.
Make the whole car bomb.
Okay. I know the biggest press that I've seen is Wyden Gordon up in Mass, 46,000 ton closed die press. I can't remember how heavy it was, but you know, the bed of the press was as big as this room and wider. You know, just it was huge, and they were doing the behind the guys in the fighter jets. I forget what that's called, that wall there, but they were forging them out of titanium in a single shot. Next. So here we are stacking the press up. Next. Next. And then we brought the welding crew in behind us to weld all the columns. Again, if you torched them, they would have been, it would not have been easy to re-weld that. So the welding crew came in and welded the 4 columns. Next. And there's your press. Next. You guys are familiar with that view? Next. Things that we had to overcome: avoiding the mechanical disassembly, unable to lift it as a single piece, no usable data on the press, the structural integrity of the press crown, the anvil was broken, the grade differences between the bottom of the pit, the bottom of the circle, the routing around the historical buildings, and rigging in the media event. Now, we had the opportunity, we're part of an organization called the SCRA, Special Ice Carriers and Riggers Association, and that's an international organization of all of the large rigging companies around the world. And we had the opportunity to enter this project in the rigging job of the year, and they have different categories. So they have the up to 150,000, 150,000 to 750,000, the over $2 million category. They have some big transportation, and so we had the opportunity. Next. So we actually won the category of rigging job of the year with this project, and that checked off a bucket list item for me, and our company and our team. Some of the projects that we competed against, there was a bridge where they put a whole bridge in one piece in Italy. They moved a regen reactor. It was 1.4 million pounds for a nuclear power plant. Largest piece moved on rail in the state of Nevada. Some of the projects that they had just blows my mind of some of the stuff that we're doing and the engineering feats that they're doing. They had one column 185 foot long. If you ever go to see a refinery and you have these tall columns, and the bridge couldn't take the weight, they crossed the road, and there were 2 bridges, and they took it across half of the trailer here, half of the trailer there, 185 foot wide on 2 bridges, so they could take the weight. So we had the opportunity, and thanks, Jim, thanks for your faith in recommending us. Kara, Andrea, and Charlie, thank you for the opportunity for us to work on this project. It was a neat project. Tony, in our office, he saw, you know, he could envision this project, and he was pretty stoked about it, and we're glad we had the opportunity to do it. It was kind of neat from the first meeting we had at the casino when Andrea and Kara were high-fiving themselves when we came out of the meeting. I don't think I have anything else on the slide there. Oh, this is from the cover of the ACT magazine, which is the SCRA magazine. There's our project up there. Here are some of the other projects that we were competing against. The one in the center of the cover is the Regen reactor. They won for the trucking job of the year, over $2 million. There is 3 tractors pulling it, 4 tractors pushing it. Up in the top right corner is the walkway at the Seattle airport, where it was a walkway that went right across the taxiway, so they had to put it up in one night. It was, I think, 2,300 tons. They picked it up in one piece and put it in there. And then this is the feature in the ACT magazine. Any questions?
Where did the trailer with the 10 axles, where does that come from?
It actually came from New Jersey, a company called Supa. And it is a for our industry, it's something that's available. Not every company has them, but they are available. They're really made for off-road type applications. That was a 10 line. They'll take 168 lines, bolt it all together, and move big pieces. Some of the bigger things that I seen move was an offshore drilling rig, and they did the whole drilling rig and on the SPMTs, took it out to the ship side, and then they used a 10,000 ton barge crane to pick it up. And the order of magnitude, the hook on this barge crane weighed 152,000 pounds. Just the hook. So, any other questions? Yes.
Was there ever a point in time that you had serious concerns about whether the project could be completed?
No. No, I mean, was I going to get it done the day that I said I was going to get it done? There was it's always concerns. When the wire sawing took 2 days longer, schedule. But one of the things Tony had said to me over the years is a success of a job is planned before you start. And if we're not confident in what we're doing, you shouldn't be doing what you're doing. But I would say there was no, convincing people that what we were doing, was the right thing. But no, there was no time where we didn't convince.
When you welded the columns back together, the 18-inch columns, you put a spacer in the middle and then weld inside and build it all the way out, make them solid, or is it just on the outside?
No, it's just on the outside. Yeah. So we beveled them, and it's just on the outside. It's not forging, so it doesn't see. It'll stand up there without a weld on it. As long as there's not an earthquake.
Was there crack in the anvil all the way through the anvil?
Yes.
So you didn't have to weld straps across?
Well, there were some bolts that went all the way
Okay.
across. They were maybe 1.5 inches that were installed sometime in the past,
That kept-
but there was a big gap. So
Right.
my concern was when they bolted it together, there wasn't a gap this big. So were the bolts still intact? Or were they stretched, or were they broken? So the way we designed the lugs, it picked it up even on both parts, and the force of it just pressing against each other kept it up and level.
Wow.
Okay. Go ahead, Karen.
Sorry, could you just remind me again, how you got your start in the business? I love this.
So, it was a family business, but we started as bakers. So, we used to bake, and we used to bake for the school systems. We used to make pizza, and we did the football games, and we'd move our ovens from stadium to stadium. And my dad was always an auction guy, and during the summertime, the bakery was slow because we weren't baking for the schools. So he'd buy and sell bakery and restaurant equipment. Then we started moving bakery and restaurant equipment. And I had 3 older brothers, 3 younger sisters, and we all worked in the bakery. And I'm the 4th down. As my brothers got old enough, they left. They weren't gonna, when they got out of high school, they were gone. So before I got out of high school, my dad saw the writing on the wall that there's nobody gonna be left in the bakery business, so we didn't open the bakery up again 1 September, we just stayed in the equipment business. And so at that time, it was 90% equipment and 10% moving. We were moving bakery and restaurant and supermarket equipment, and that would have been in the 70s. And when I got out of high school, we were really more just moving equipment, was more 80% of our business. So that was back in 81. So coming up on 41 years doing this stuff. So we were rolling in the dough back then. Thank you. And this is incredible. So someday when I have grandkids, I'll get